This video is on ionic bonds. Ionic bonds form as an electrostatic force that holds ions together. So actually they're not really bonds, but they just form compounds. It's more like an ionic interaction between a positively charged cation and a negatively charged anion. So we don't write ionic bonds, we have ionic compounds. Electrostatic forces occur between cations and anions, and we've talked about where we find cations, the metals, and anions are nonmetals. Ions form by either donating valence electrons or by accepting electrons to form a full or empty outermost energy level. Metals are going to donate electrons and become cations. Nonmetals are going to accept electrons and form anions. So think back to our trends and we learned about ionic radius. Remember that ions are aligned with the different groups on the periodic table. Their valence electrons are equal to their group number if we exclude our transition metals. So we number from the left, 1 through 8 on the right, and we skip our transition metals in the middle. Remember we have our staircase dividing line. Anything to the right of that are nonmetals, forming anions, negatively charged ions, and to the left are metals, forming cations, positively charged metals. Remember to group numbers excluding your transition metals, and that these numbers at top are equal to our valence electrons. Remembering again, they either want to get to 8 or 0, whichever is easier, gaining or losing their electrons. We need to know how to name ions, that way we can eventually name our ionic compounds. Metals form cations, and they are named by just the name of the element. So looking at calcium, calcium on your periodic table is in group 2. Therefore, calcium is going to be calcium plus 2. To name that as an ion, we just write calcium. Aluminum, we find on our periodic table, here is in group 3. Again, being a metal to the left of the line, aluminum is going to make the ion Al plus 3. We name that in an ion form as just aluminum. Our nonmetals again form ions, and they are named with the element stem, and we use an IDE ending. So sulfur, which is in group 6, forms the ion S-2. As an ion, we call this sulf for the stem, and then we add our IDE ending, so we get sulfide. Same thing with fluorine. Fluorine is in group 7. It's going to gain one more electron to have a full octet and become fluorine minus 1, and it's no longer fluorine, but rather fluoride. This is what's in your toothpaste. So how do our ionic compounds form? Well, we know that our cation is going to give an electron to our anion. We need to be able to draw this to see what's actually going on. We'll start with our first example of calcium and sulfur. Calcium, just like we talked about before, makes the ion Ca plus 2. Sulfur, we said, makes the ion sulfur minus 2 to make sulfide. Next, we need to draw Lewis dot diagrams. A Lewis dot diagram is our element, so calcium, and then its number of valence electrons are first by themselves and then paired. Calcium has 2 valence electrons.